Okay, yesterday we are talking about sources of protein, complete source of protein. As I told you, all the most animal source, that may be dairy product, that may be meat, or that may be uh, eggs. All the animal sources contain complete source of protein. Okay, I will make you host.
Sir, yesterday you asked us to make a list of steroid hormones and protein hormones.
Yeah. So have you completed that?
Yeah, I tried to do it.
Okay, so how many hormones are steroid hormone there?
Sir, there are three major categories:
Mm-hmm.
mineralocorticoids,
Yeah.
glucocorticoids,
Huh.
and gonadocorticoids. In mineralocorticoid, we have aldosterone.
Aldosterone. All these hormones are released from adrenal gland.
Yeah,
Okay, so
and
except these
there is the gonadocorticoids are released from the gonads, which are androgen, estrogen, and progestin.
androgen, estrogen, progesterone. Yeah, these will be released from gonads. So these are also steroid hormones.
Yes, sir.
Okay, very good.
And
Except these, is any other hormone steroid hormone?
no, majorly these three categories.
Okay, major these three hormones are steroid hormone. Very good. You need to remember that there may be question asked in they can ask question in exam like which of the following hormone is steroid hormone, and there is also some difference in working of steroid hormone and working of peptide hormone. I will just give an introduction here. Why steroids are considered bad and why steroid hormone uh, are that much effective, and why steroids, like some substances which we use as steroid, why they are considered bad for our health. Actually, what happened, hormones have two mechanism to work. Like, first mechanism is for peptide hormone. What peptide hormone does, like a peptide hormone, this is our cell. A peptide hormone will bind with the cell membrane of this cell, and then the cell membrane will send a signal inside nucleus to work on the this hormone order. So if some cell receive a molecule of peptide hormone, this cell will send a intracellular messenger. There are various type of intracellular messenger for various hormone. This cell will send intracellular messenger to the nucleus, and on the response to that intracellular messenger, the nucleus according to hormone. For example, cell of thyroid gland. This is cell of our thyroid gland. This cell receive hormone TSH, thyroid stimulating hormone. This is released from pituitary. What this hormone will do? This hormone will bind to the cell membrane of thyroid cells, and in response of this thyroid cell, this TSH, this membrane will send a messenger to nucleus, and in response of this intracellular messenger, these cell will start producing thyroid hormone. This is working of normal peptide hormone. What steroid hormone do? These steroid hormone, or which we consider as steroid, that may be a non-hormone, some other compound which generally people take as a medicine, as a bodybuilding supplement, which these all categories of steroid, what they do, crosses the they just crosses the membrane. They do not bind with this membrane. They just crosses the membrane and bind to nucleus. They directly bind to our nucleus, bind to our hereditary, that is DNA. That's why steroid hormone or steroid substance, these are very fast in working, because without binding with this cell membrane, they directly attack, or they directly bind with the genetic material and apply changes in the cell. So if these steroid are working fine, then these will work very fast, these will work very good. But if there is some problem with the working, if the genetic material is not changed according to plan, and if there is some mistake, and if there is some over changing take place in genetic material, then these are very, very dangerous. If the genetic material will get changed once, then it will be lead to whole progeny, like in children's also, that we can say that change can be seen. So that's why steroid hormone are different from peptide hormone. This is their working mechanism. And you had made that list. Please try to remember all those steroid hormone, all those peptide hormone, because question also can be like this: which hormone directly binds with the nucleus, which hormone binds with cell membrane. So these are two categories of hormone, and this is their working mechanism. Okay,
Sir, I
so
have a question. This is a
yes.
little because this is a little diverting from the main topic, but I would still like to know about it.
Mhm.
Sports people, they take steroids and they get caught for
They,
their extraordinary performances. Like mm,
yeah,
sometimes, what does the steroid hormone do? Does it boost the energy in the body, or how does it work?
okay. Like as I told you, the normal hormone, what the normal hormone doing? It is just binding to this membrane. It does not have access to cell nucleus, cell hereditary material. But steroid directly goes inside the cell, and uh, they directly joined with the our genetic material DNA, and made the DNA do some work. They make changing DNA. That's why the steroid work very fast. They have very a good result in a very short period of time. It's like, if you want to do something, if you want to do something of your work, first you can go through hierarchy. You will ask your teacher, then he will ask your principal, then he will do some work. But steroids are like, they will you are directly talking with some MLA and all, and he is doing work for you. So steroid are directly joining with the genetic material and making things very fast. They can increase our ability. They can also increase our natural ability by just changing this genetic material. Actually, whole of our body is made up of on the programs of this genetic material. But if this genetic material get changed, if this genetic material is changed and is programmed like increased stamina and increase some muscle mass, then our body will increase stamina, increase muscle mass unnaturally. So because of changing genetic material, these things are considered very harmful and unethical.
Okay, sir. Thank you, sir.
Okay. Okay, so let's again come to this topic. We are talking about complete and incomplete protein. So uh, this we yesterday talk about, like two proteins are there, complete source of protein. Dairy product are complete source of protein. On the basis, what is the basis to classify between complete source and incomplete source?
Sir, the 9 essential amino acids are there in the complete
Yes.
protein.
Very good. So a food source containing all 9 essential amino acids, we will call that source a complete source of protein. But if some source is lacking some important essential amino acid, then it will be called as incomplete source of protein. All the plant source except some like quinoa, buckwheat, and soya bean and all the other sources are incomplete source. So as I told you, vegetarian have to complement protein in their body. I will share a picture with you. Okay, these are complementary protein. Is this visible to you?
Yes, sir.
Okay, first let's understand the concept behind this complementary protein. Complementary protein means if something is lacking in your main food, like for example, you are having peanuts, and peanuts, some X amino acid is lacking. It can be anything. It can be alanine, it can be valine. So in, for example, in peanuts, uh, some X amino acid is lacking. They may be one, they may be two. And what to do now? So if you are having peanuts, so with peanuts, try to take something which have this X amino acid. This is called complementation of protein. If you are having something and that thing lacks some specific amino acid, then you can take the amino acid from some other diet sources. This is called complementation, and in general we are doing this, but we should be aware of this. Like what happens mostly, we are depend on legumes like peanuts, beans, lentils. These are the major protein sources for us. We can have peanuts, we can have bean, it may be kidney bean, it may be some other bean, but we are dependent on these legumes. But these legumes are not complete source of protein. So in general, we are already having these grains with these legumes. So this is one simple formula. Like if you are having legumes, you should add also grain with that. Then it will be a complete source of protein. Wheat, corn, rice, these are our grains, and it should be combined with legumes. That's what we are doing. But sometimes it also fails to deliver whole amino acid into our body. Then there is one more option for us, and we should include that. That is seeds and nuts. So in a day, for your complete protein requirement, try to add lentils or legumes with grains. These two things we are already having. Try to have this in a good quantity. Like what we mostly do, we mostly eat more grains and less lentils. What we are doing, we are eating less, more rice, more chapatis, and less dal. So we also have to increase our lentils and legumes consumption. And with this grain, we also should have some seeds and nuts. Seeds can be pumpkin seeds and all, and nuts can also be introduced in your diet. So if you are taking this composition, then all the essential amino acid your body will get. Lentils and legumes with grain, and these should be taken with seeds and nuts. You can have sprouts for that. There are various recipes for that, and you can also search protein complementation or complementary protein. You will also get some dishes which contain this complementary protein. Okay, this is protein complementation. Complementation of protein means if some source is lacking some amino acid, we will have that amino acid in some other diet. So for vegetarian, this complementation is very, very important. You must have all these in order to complete your protein requirement. And you should always focus on this group and this group. Have lentils and legumes in good quantity. have seeds and nuts in good quantity. And especially for children, this is also very, very important. Seeds and nuts are also source of some good fats. And if we go through some uh, if we go through some ethical or moral values, and also if we look from some health perspective, this protein complementation, this complementary protein is very good or very better source than non-vegetarian sources. In non-vegetarian sources, although you are getting whole protein, but those protein are always in excess that may increase your nitrogen and urea level. And second thing, they contain some bad fat. These good fats and bad fats we will discuss in the fat topic. Now let's talk about protein needs. So protein needs, this is percentage. Like if you are having a diet, then 10 to 35% of energy should come from protein. But in RDA, recommended dietary allowance, there is zero point 0.8 gram. Now we will explore this more. Okay. Okay, zero point 0.8 gram per kg of body weight. 0.8 gram, this is our actual protein requirement. This you also have to remember of our whole complete diet. 10 to 35% of that energy comes through protein. And this is also in gram. This is just an example. If you are having 2000 calories, then 200 to 700 calories should comes from protein, and for that you have to take 15 to 175 gram of protein. It is just a example. Main value is this: 10 to 35% of your whole calories, 10 to 35% should come from protein. There is one more method to know this protein need of our body. If you are having if you are a adult and you are not doing some practice that needs increased protein intake, then the general protein intake is zero point 0.8 kg per 0.8 kg per kg of body weight. For example, you are having, okay, 0.8 grams, sorry. If you are having 40 kg body weight, then just multiply it by zero point 0.8. It will be around 32 gram. Then your body needs 32 grams of protein. I will open a whiteboard. Okay. So 0.8 gram per kg of body weight. If you are having 40 kg body weight, then multiply it by 0.8 and the value will be your protein requirement for a day. It is 32 gram. Similarly, if you are having 60 kg body weight multiplied by 0.8, it is 48 gram of protein. 48 gram of protein then needed for your whole day. Now let's come to some situation where you need more protein. First one is pregnancy. Other one Is lactating mother. Obviously, they both the condition need more protein. Third one, if you are having some disease, then also protein is needed. Why in disease protein is needed?
Because protein builds the structure.
And which structure protein is building that will help in disease?
It builds the muscle.
No. As I told,
Immunoglobulin.
yeah,
Repair the
immunoglobulin,
disease.
antibodies. Antibodies are also made up of protein, as I told you earlier. Now,
Yes, yes, sir.
antibodies, protein will be needed. These three condition. Fourth condition will be growing children. So these four condition needs more amount of protein. If you are doing some hectic physical activity, if you are doing some hard physical activity, it don't need that amount of protein because it will need more amount of energy. But as you are not growing your muscle, then it's okay with 0.8 gram. All these condition needs around 1 to 1.2 gram of protein per kg of body weight. It will be around, if we goes through this 1.2, if you are having body weight 60, then we will multiply by it 1.2 gram, and 72 gram will be your protein intake. So for all these condition, pregnancy, please note these condition down. Lactating mother, if you are having any disease, and if you are a growing children, or if you are having growing children in your home, so all these condition need much protein. Now a condition need much more protein, that is if you are working on your muscle building. If you are working on your muscle, if you are muscle building, if you are doing muscle building practices like resistance training, gym and all, I'm not talking about yoga, I'm talking about those practices in which the goal is just muscle building, then you will need around 1.5 gram of protein per kg of body weight. So 1.5 gram, if someone having 70 kg body weight, then uh, it will be around 105 gram of protein for a daily diet. So this 105 gram is not possible by taking from natural sources like lentils, like legumes and all. So these people take protein shake. There is no we can say there is no harm in taking protein shake, but you should check the quality of protein shake, and you should be sure that you are doing some muscle activity. If you are taking protein more than your body requirement, then it will be ultimately converted to urea. It will increase your urea nitrogen. And what will happen if we are taking excess protein? Let's discuss that. You can note that down. If you are doing some muscle building, it will need 1.5 gram per kg of body weight. Now, what will happen with excess protein? Excess protein is also very harmful for our body. What happens with excess protein? This excess protein is converted into urea and uric acid. Now, why this excess amount of urea and uric acid is bad for us? Two organs are affected in this process. First organ, which is converting this excess protein into urea and uric acid, that organ is liver. So people who eat frequent non-veg, who take frequent more protein than their requirement, first organ affected is liver, because liver have the pressure to convert this excess protein into urea and uric acid. Second organ, which it can be, second organ can be,
Kidney.
Kidney.
yeah, kidney have the pressure to eliminate this urea and uric acid out of our body. So what happens if the urea or uric acid levels increases in our body? Kidney have the pressure to eliminate it out of our body, and slowly kidney started degrading. And kidney failure, the prime reason of kidney failure is having excess protein, or is having bad quality of protein and having some non-vegetarian diet and protein shake and all. In most of the kidney disease, it is always advised to limit your protein intake. If you are having nephritis, if you are having a kidney stone, then doctor may recommend you to limit, to decrease your protein intake, so that your kidney will not face extra pressure. So excess protein leads to these two conditions, urea and uric acid increase, and affect these two organs, kidney and liver. One more thing is there, when we start aging, slowly our kidney power of our kidney start decreasing. So it is also advised to old people, because their kidney has degraded very much, their kidney is not that much powerful. So it is advised to old people to slowly limit your protein intake, to slowly decrease your protein intake, because their body is in degeneration phase. They don't need much protein uh, to grow muscles in their body. Their body is already in degeneration phase. So there is no point to take excess protein. So they should limit their excess protein. They should limit the non-vegetarian diet completely. They should avoid non-vegetarian diet and to limit their protein intake, so that there will be less urea and uric acid accumulation in our body, and less pressure will be on their kidney. This urea and uric acid, if accumulated in our body, then what happens? It mostly accumulated in our joints. And this accumulation of urea and uric acid in joints is very much painful, and we call this condition as
Out.
gout. Yes, very good. Gout is accumulation of urea and uric acid in joint. All these conditions are arised because of increased protein intake or excess protein in our diet. So to control that protein is also very much important. For who are taking non-vegetarian diet, those people should limit their protein intake. Those people should have an eye on their protein intake, whether it should not be more than the recommended protein intake. But for vegetarian people who are not taking any type of protein shake and all, they don't have this danger of increased protein intake. They have danger of decreased protein intake or protein deficiency. So now let's talk about protein deficiency. All this you will find in the slides. Okay, so if protein is being deficient in our body, if you are not having proper amount of protein, the values which we discussed, if you are not having that amount of protein, then what will happen? Protein will be deficient in our body. And what can be the symptoms? What can be symptoms of protein deficiency? Okay, this is not here in slide. Please note it down. I will try to include this in slide also. Major symptoms of protein deficiency. So if we are having protein deficiency in our body, then all the function of protein will be affected. What is the major function? Major function is to build our body framework. or antibodies or different types of function of protein we had discussed. So what happen in protein deficiency, all those functions get affected. And as I told you, if there are two types of protein deficiency, one is amino acid specific and one is complete protein deficiency. Amino acid specific protein deficiency, in which you are taking good diet, you have availability of good foods, but because of your selection some amino acid are getting deficient in your body. In that condition you will face a specific problem like hair loss. Those protein that are responsible for regeneration of hair, that are responsible for giving strength to hair, if you are lacking those amino acid, then hair loss can occur. Similarly, brittleness of nails, your nails can be brittle. Loss of appetite, this is acid specific protein deficiency. If you are having complete protein deficiency, means most of the amino acid are deficient in your body, then there will be muscle shrinkage. On the basis of deficiency, these two deficiency are there: amino acid specific deficiency and complete protein deficiency. Now let's talk about two disease. Forget about this. uh, have you written this?
Yes, sir.
Okay, is there any doubt? Is there any doubt till now?
No, sir.
Okay, now let's talk about two very important disease. Two or three times these diseases are being asked in exam. One is kwashiorkor and the other one is marasmus. Kwashiorkor disease and marasmus disease. Most of the students are very much confused in two diseases, kwashiorkor and marasmus. We will not talk about symptoms. We will not talk about uh, these diseases, like what is the physiology and all. Just we will see by perspective of protein these two diseases, kwashiorkor and marasmus. So we will also just discuss by examination perspective. Kwashiorkor and marasmus, both diseases are deficiency disease in and occur mostly in children. So you can write both two are deficiency diseases that mostly occurs in children. Now, what is the difference? Kwashiorkor is just protein deficiency or protein malnutrition. Marasmus is PEM, protein energy malnutrition or deficiency. That means kwashiorkor, our body is only limiting protein. Protein is deficient, but in marasmus, with this protein, energy is also deficient. So, what is the source of energy in our body?
ATP.
ATP is source, but from where that ATP get produced?
Carbohydrates.
Carbohydrate. Yes,
So, yeah,
carbohydrates.
carbohydrates.
Yeah, up to some extract fat. Fat are also providing energy. As I told you, fat has very high calorific value. So in this marasmus, with protein, energy is also deficient. Energy means carbs and fats. These are also deficient. Now, this is the primary introduction of kwashiorkor and marasmus. So let's talk about prevalence of these diseases. Prevalence means how these diseases being spread in our society. So quasi-occur, what leads a child to quasi-occur? Quasi-occur mostly seen in the rich countries and well-to-do families, that those are having good financial background. Well-to-do families. What happens, these families has good availability of food, they are having good food sources, but because of their selection they are having such things which do not contain protein. As you can see in America and all, the major food source is like burger and all, that do not contain protein at all, that may contain fiber in the form of cucumber and all, but that do not contain protein. So if you are having some good food sources in which you are taking lots of energy, but that food sources are not good according to protein perspective, that food sources do not contain protein. If your dietary habit is like this, slowly your body will start protein deficient, and this condition is known as kwashiorkor. We will just talk about one major difference in kwashiorkor and marasmus. What happens in kwashiorkor with the child? The child muscles start shrinking, all the hands and legs will shrink, just he will have a we can say a big stomach, enlarged stomach. In your surrounding, if you are seeing any child like this, or even adults, some adults don't have good build around their muscles, but they are having big stomach. That is because of this protein deficiency and increased intake of energy, increased intake of carbohydrate and fat. This is major difference. Now let's talk about marasmus. Marasmus is prevalence in poor countries or some not well-to-do families, children of not well-to-do families, that they may face marasmus because they don't have much access to food, because it is very bad condition, like very, we can say in this condition they don't get proper amount of food, they don't get good quantity of food. So if they are not getting good quantity of food, their protein requirement is not fulfilled, their carbs requirement is not fulfilled, their fats requirement is not fulfilled. So they are having deficiency of all the macronutrient, plus they may have, or they will definitely also have deficiency of vitamins and all. So this condition is known as marasmus. In this, not access to food. So in this condition, there is no enlarged stomach, there is no big stomach. Your whole body, if anyone is having marasmus, whole body will shrink, even stomach, even muscles, whole body will shrink. So these are two different diseases, kwashiorkor and marasmus. One is prevalence in rich countries and other is prevalence in poor countries. All these two diseases are clear. Is there any doubt?
No, sir.
Okay, so please note it down. We will just take 1 minute pause. Please note it down. It is not in PPT. I will try to include, but please note it down from your side.
Sir, is marasmus also malnutrition?
Marasmus, malnutrition means some kind of deficiency. In marasmus, this is a malnutrition of both protein and energy. In kwashiorkor, there is only protein malnutrition.
Okay, sir.
Okay, now let's talk about protein digestion. I will try to simplify that protein digestion here. You can, after this class, you can read that PPT. There you will find that digestion in whole detail. We will just try to understand it here. So if we talk about just macro version or macro explanation of protein digestion, what is happening in this world, what is happening, how different organisms uh, are getting protein, how they are using protein. Like we intake protein from our source, it is like a complete protein. This protein, when we digest, protein got broken down into
Amino acid.
amino acid. These are small amino acid. It may be any source of protein. Let's we can name it as lentil. It may be some lentils. Our body, we just ate that and our body digest it into amino acid. This is called digestion of protein. What happens after that? These amino acid are being carried out in our blood. And from our blood, our body, those cells who required amino acid, they will absorb these amino acid from blood and they will form their required protein. This will be transported to cell and they will form, with the help of these amino acid, with the help of these building blocks, they will form their own building, they will form their own protein. Like for example, our body cell may produce hairs from these amino acid. So which cell organelle is responsible for synthesis of protein from amino acid?
Lysis. No. What is?
Ribosome.
Yeah.
Ribosome is kind of factory. We just, our body just provides ribosome some amino acid in form of raw material and it produces our desired protein. Now inside our body, who is directing this ribosome that you have to produce this kind of protein?
DNA, RNA.
Yes, very good. DNA and RNA. These two are guiding this ribosome. That's why they are our genetic material. Okay, this is complete metabolism of protein in our body. Now let's talk about how this digestion will happen. Two places are site of protein digestion. First one is stomach and other one is small intestine. Stomach, there is one enzyme which gets secreted from walls of stomach, that is pepsinogen. This is inactive enzyme. And this is secreted from walls of stomach. I forgot that gland's name. It is secreted from some gland that are situated in walls of stomach and
Sir, B cells, sir.
B cells,
No, G.
G cells. Okay, it may be, actually I forgot. It was like okay, you can check that. So these cells, maybe there's those cells. Those cells secrete pepsinogen. This is inactive enzyme. This pepsinogen react with HCl and this form pepsin. This is active enzyme. This HCl is secreted by some other cell and they just met in stomach. This is stomach. They just met in stomach and react inside this stomach. So this pepsin convert protein or break down protein into amino acid. So one question arises here, why our body secrete this enzyme in inactive form?
Because it might digest the body protein, the cells also. This
Yes, very good. If it was in active form, our body is also made up of protein. That cell who are secreting this, those are also made up of protein. So if this will be in active form, this may digest those cell itself who are secreting this. That's why it is always secreted in inactive form. Inside stomach where there is layer of mucus, this got mixed with HCl. It is then being activated into pepsin. This pepsin is active form, and this protein digested into amino acid. Okay, now let's talk about digestion in small intestine. What happens in small intestine? Pancreas secrete two hormone. First one is trypsinogen. If you are if you get this term enogen, then it is inactive form. The other enzyme is chymotrypsinogen. Chymotrypsinogen. Sinogen. These both are inactive form. Now, which is activator of these two inactive enzyme? Just like pepsinogen has activator HCl.
Sin.
Huh?
Uh,
That is released from our small intestine. Enterokinase. Have you heard about that? This enterokinase, just like HCl, activates this trypsinogen into trypsin and this chymotrypsinogen into chymotrypsin. So again, on activation, this trypsin start digesting a protein into amino acid, and same function, this this chymotrypsin then will start digesting protein into amino acid. So this is digestion of protein. First step happen in stomach by pepsin, and other step happen in small intestine by trypsin. Is it clear?
sir, what is the end product of the protein digestion in small intestine?
Amino acid. Protein always be broken down into amino acid.
So when these pancreatic secretions, trypsinogen and chymotrypsinogen, get
Hmm.
mixed with enterokinase,
Yeah,
it forms trypsin, which is an active enzyme.
it will form trypsin and it will form chymotrypsin.
Okay, so those two active enzymes will act on the protein and convert it into amino acids in the small intestine.
Yeah, that is protein digestion. Then those amino acid will be absorbed to blood vessels. Okay, so this is all about protein. We have discussed everything about protein, protein deficiency, excess of protein. Uh, is you are having any doubt? Is there any doubt you can ask? If you don't have any doubt, you can leave from tomorrow. Yes.
Um, when the protein digestion starts in the stomach, certain part of the protein will be broken down or digested in the stomach itself, and what remains goes into the small intestine, and then it gets completely digested, sir. Is that the way?
Yes, yes. Some
Okay.
part of protein digested in stomach and remaining part, and most of the part digested in this small intestine.
Okay,
Okay,
sir.
so okay, we will stop here. From tomorrow, we will start new topic fat, and then we will continue this from fat. So you can leave now. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.